All right, Chem 11 students, our next topic is percent composition by mass for a compound. Very, very easy calculation to do in chemistry. It's like basically finding out the percentage on a test, right? If you can calculate percentage, if I gave you, this is what they got, this is the total marks on the test, and you can calculate the percentage from that, you can do this. This is not hard. Anyway, what you're going to have with you in order to do this is a periodic table of the elements. Check, I've got one of those. Beautiful. And a calculator. Maybe yours is as stunning as this little number here I got from the Dollarama, one of the greatest stores on earth. Anyway, if you got those two things and a pen and paper and your brain is up, ready to work, then you're ready to go. You'll do this no problem. So let's get into it. I'll erase this. The Sumo and the baby. We'll figure that out in a sec. Why it is called that. So, what is percent composition? All right. Percent composition is the proportion of elements in a compound expressed as a percent. All right, so I'll write that out for you. This is something that it's a short topic, so it's normally something I would just write on the board for you. So percent composition is the proportion of elements in a compound expressed as a percent. All right, so our answers are all going to be in percent. Now, there are two ways to do this. One of them is the wrong way and one of them is the right way. Our percent composition is by mass. All right. So here's what I'm going to do. I'm going to draw a simple little couple of stick figures. So think of a sumo wrestler. They're usually pretty big, right? And think of a baby. We'll have the sumo wrestler holding the baby. There you go. So I've got my sumo wrestler and my baby. If I look at that in terms of simple, just numerically speaking, like strictly numerically, I've got one baby and one sumo wrestler, right? This is the way we don't want to do it, by the way. So if I look at it strictly numerically, right? So if I go strictly numerically, this situation, one baby, one sumo wrestler, it's 50% each. Right? It's a 50-50 situation. There's two things, or two people. One of them is a little baby, one of them is a sumo wrestler. We don't want to do that. That's the way we're not going to approach this. We're going to do this. Right? 3 exclamation marks. That means I'm serious. So let's look at it by mass. If I were to put them on a scale, the baby might be 10, 12 pounds. The sumo wrestler is going to be a few hundred pounds, right? These are big, big guys. So in terms of the mass of this compound, these two different things together, one of the elements or characters here has way more mass than the other one, right? A good example of that is lead 2 oxide, right? Lead 2 oxide is PbO, right? The lead is a 2, it says here that's a 2, oxygen's a 2, they cancel out, so I get PbO. If I look at the individual masses of the elements, lead is got an average atomic mass of 207.2. Oxygen is 16. So even though strictly numerically I've got one of each, I know when I look at the actual amount of stuff that's in there, the protons, neutrons, the mass of this thing, Most of the mass, most of those electrons, protons, and neutrons belong to the lead. Very little of it belongs to the oxygen. In this case, our sumo wrestler is our lead and our baby is oxygen. All right? So this is the way we want to do things. We want to use mass. All right, I'll underline it again. So we're doing our percent composition based on mass. So we're going to need the masses of the elements involved, and that's where our periodic table comes into play. Because our periodic table, of course, has all the average atomic masses that we'll be using for each of the elements, right? So our next step is our how to do this. So what I like to do with all the stuff in our quantitative chemistry unit is break it down into steps of how to. And if I go through each of these steps and I do them properly, I should arrive at the answer. So what I'm going to do is I'm going to put percent composition up here. And we'll remind ourselves it's by mass. And this is the how-to, right? So step by step, if we follow these steps, we should be absolutely fine. The first thing I need, number one, I need to know the formula. I have to have the formula of the compound. All right? Number two, I got to find the mass, because it's by mass, of each element in that compound. All right? Did I get the mass for each element in the compound? The second thing, I'm going to take the mass of each element and divide by total mass of the compound. All right? So did I do that? I'll put a question mark here, meaning did I do this? Did I do that? Did I do that? And then I'm going to multiply like we do to get a percent by 100%. This is multiply. All right, that little X. So let's do an example, and we'll do lead 2 oxide to start off since we already kind of got into it. So for example, what is the percent composition of lead 2 oxide? So this is what I have to do. All right, I've got to get the percent composition by mass of lead 2 oxide. Let's go through our steps. Formula. I know the formula. The formula is PbO. All right, lead is a 2, oxygen's a 2, the two 2's cancel. PbO is my formula, that's good. Again, names and formulas coming into play here, like we said. Number one most important thing in chemistry is names and formulas, right? So next thing I have to do is the mass of each element. So I've got my Pb and O. I'm going to separate them. Lead, I know, is 207.20. And we're going to use grams here because we're talking about mass, all right? The unit for mass is grams, all right? So lead is 207.20. I got that, of course, off of the periodic table. Lead is down here. It's 207.20. Oxygen is up here at 16. So that periodic table, important again. So number one, I did. That's the formula. Number two, the mass of each element. I have 1 lead and 1 oxygen. 3, divide by the total mass of the compound. So what I'm going to do here is I'm going to add up my lead and my oxygen. So I can take these two numbers here and I can add them together. And I'll end up with 223.20. And because it's mass again, it's going to be in grams. And I do the same thing here. That's step 3 done. And the last one, step 4, is multiply by 100%. Oh, I had the new kids on the block, step by step, playing in my head there. That's why the little pause. Anyway, different steps, different song. I'm not even singing. But There's my 4 steps. So if I do the calculation now, look what happens, right? If I look at this, grams divided by grams will be no grams, right? That cancels out. Grams divided by grams cancels, right? So my G's are gone, and the only unit left is the percents. So that's great. That's what I want. Percent. All right. And when I take this number and I grab the old Calculator-O-Matic 3000 here from the Dollarama, one of the best stores on earth, and I put the numbers in, this one comes out to 92.83%. There's a decimal there. And this one is 7.17%. All right. A simple check. If I include all the elements, it should add up to 100%. Now, of course, this compound only has 2 elements. So if I add up the percent for the lead and the percent for the oxygen, it should equal 100. And in this case, it does. Now, the odd time, you may end up, you know, it should be 100% when you do the check. And I add those two. This one worked out perfectly to 100%. If you get 99.99, that's fine. That's okay, because sometimes you round things off and you're up, you know, a little bit. Or 100.01, that also is okay. Rounding off is going to make little, you know, it doesn't have to be 100.0 every time. These are both acceptable. It's going to happen with rounding. All right. You should not get 102 or 97. It shouldn't be that. It should be one of these 3 usually. All right. This one just happened to work out perfectly. All right. So that's our answer. Pause this video right now. Take that in. Write it down into your notes. I'm going to set up. We're going to do 2 more great examples with you. Get this down into your notes right now. So this is our final answer here in the black. That's our percent composition. Again, it's not a 50-50 at all because we're doing it by mass, right? If I had a dump truck full of lead 2 oxide, most of the weight in that truck is going to be from the lead. Just like if I had a dump truck and said, okay, Sumos, grab your babies, get into the truck. What's most of the weight weighing down that truck going to be from? Not the babies. It's going to be from our sumo wrestler, the heavy lead, right? Only a little bit's going to be from the baby. So it gives a more accurate reflection of when we go into a substance, what makes up the bulk of that substance. In this case, the lead represents a lot more of the material atoms, protons, electrons, and neutrons belong to the lead. All right. So I'm going to erase this and we'll do another one. All right. Excuse me. Our next compound is going to be, let's do glucose. All right, so we're going to do the percent composition of glucose, the fundamental fuel of all living things. So again, step 1, formula. Glucose is C6H12O6. The biology kids can help you out with that if you didn't know. So this is the sugar that plants make in photosynthesis. So its formula is C6H12O6. So now what I'm going to do is I'm going to break that down into my 3 elements. All right, I've got carbon, hydrogen, and oxygen involved here. So I just broke it down into carbon, hydrogen, and oxygen. Now, I can't use 12.01 here because the mass of carbon, 1 carbon is 12.01, but I've got 6. So my mass of that is going to be 6 times 12.01 grams. Hydrogen, right, because now we're figuring out the mass of each element. We just did the formula. Now I've got to get the mass of the carbon. Well, there's 6 carbons, so I've got to do that multiplication. Hydrogen, well, there's 12 of them that weigh 1.01 gram apiece. All right, and oxygen, I've got 6. Go to the periodic table. Its mass is 16. 6 times 16 grams. All right, and what that's going to equal is this will be 72.06 grams. This will be 12.12 grams. and this will be 96 grams. So there's the mass of each element, right? A common mistake is, even though there's multiple carbons and multiple hydrogens and oxygens, someone will still put 12.01, 1.01, and 16. You have to account for the number of each one. So these subscripts, I have to bring those into play to represent the amount of each substance, each element in the compound. Now I'm going to divide by my total mass. There's an easy way to figure that out. I've got the mass of each element here. I just add up these three numbers, right? When I use the trusty calculator-o-matic 3000, I end up with that being 180.18. 180.18. 180.18. Right? So it's just like a test in a way. Like we said, percent composition is like figuring out the percentage on a test. The part over the entire thing times 100%. So we do divide by the total mass of the compound. There's step 3 right here, putting this stuff in. And then the last step, step 4, do that. And then it's just a matter of hitting the equal sign. I'll offset these. Grams divided by grams will be no grams. So they're all going to cancel, but I'll be left with percentages for each element. So again, using the trusty calculator-o-matic 3000, carbon is 39.99%. This one ends up being 6.73%. And oxygen, 53.28%. I have to kind of put them down a little bit, and in a different color so that you'll see it. So this was oxygen, that's hydrogen, that's carbon. I'm getting close to the edge of the space I can write on. Anyway, that's it. That's percent composition for glucose. All right, pretty straightforward. I'll do one more example. While I set that up, you may want to pause the video, get this down as one of your examples. All right, I would do that. Our last one is determine the percent composition of, let's go with iron 3 chlorate. So iron 3 chlorate, step 1, get the formula. I know that that's Fe. I'm really hoping formulas are becoming like just like shooting fish in a barrel, like boom, I know the formula for that, boom, I know the formula for that, boom, I can name that. That's where we want to get to in this course, where names and formulas are not a stumbling block at all. So hopefully when you see iron 3 chlorate, you see 8 is the polyatomic, and you know, if you have to nick the camel and the clams and phoenix and all that, you can do that. But and then the 3 and the 1, hopefully that's automatic in your brain now. It's starting to become a little bit easier for you. So I'm going to start this even closer because we ran out of a little bit of space last time. So we have Fe, we've got chlorine, Cl, and we've got oxygen. And again, if there's a fourth element, like say there was N3, well, I'd be putting N down here. However many elements are involved, that's it. And I go by element. I know this is a polyatomic, but we do break it up into its component elements here. So now we have to do the number for each element. Well, I've only got one iron, and on the periodic table, that's 55.85 grams. Chlorine, I've got 1 in here. Remember to be a little 1 there, I'll draw it in. And 3 of whatever's in the brackets. So I've got 3 chlorine, so that's 3 times what a chlorine, which is, chlorine is 35.45 grams. And then I've got oxygen, 3 of them inside of here. I triple whatever's in those brackets, so 3 times 3, that is 9 times the mass of what oxygen is, which is 16 off the periodic table. So this, well, that stays the same, 55.85 grams. This, when I multiply that using the Calculator-O-Matic 3000, is 106.35 grams. And then this one, the trusty Calculator-O-Matic 3000, tells me that that's 144 even grams. All right. Mass of each element. Done. All right. Divide by the total mass of the compound. So now I'm doing my dividing. I add these three numbers up, and it ends up being 306.20. 306.20. 306.20 grams. Divide by the mass of each element. Check, check, check. Multiply by 100%. So when I do that, Calculator-O-Matic 3000 spits out that this one is 18.24. And again, do the dividing first and then multiply by 100. The multiply by 100 comes after you do the dividing. It is important. The grams all cancel out. We went over that. All I'm left with is percent. So iron represents 18.24% of that mass. Chlorine is 34.73% of that mass. And oxygen is 47.03% of that mass. And that's it. That's as hard as it gets. It's not, once you get that formula, that's it. Common mistakes. Where do people lose their marks? Well, some people haven't bought in yet that names and formulas are important. So you can imagine if I put a 2 here or have made this ClO4, it alters everything. Names and formulas are of the utmost importance. You gotta know how to do those. The masses of each element, usually they do that okay. Dividing by the total mass of the compound, that's pretty straightforward. Usually they do all right with that. Again, these two numbers come off of your formula. So usually if there's a mistake here, I go back to this and realize they messed something up there. Multiply by 100% is easy. Units. Some people won't show their units. They don't write the grams in there. And anyone that's taken a chem or a physics course, you took physics 11 in the first semester, you know that if you miss units, Mr. O'Meara, Miss Burke, they're taking notes off or taking marks off, right? So make sure to show the units. Grams, mass, right? That cancels out. I know there's no grams here, but you have to show it in your work. You guys know this. You've done this stuff before. All right? Anyway, that's it. If I add these up quickly, they equal 100 right on. So it worked out perfectly. Anyway, I'm going to post a sheet on the D2L with some more moles stuff because moles is very, very important. And I'm going to include some percent composition stuff. But again, it's not hard. It doesn't matter what the formula is. The process is pretty straightforward, so we should be able to get that. Anyway, hope this is crystal clear, nice and easy for you. If you have any questions or comments, leave them in the comment section below this YouTube video or reach out to me through Edsby if you're one of my students, and I will try to get back to you as soon as possible. Anyway, enjoy percent composition, the Sumo and the baby. I'll talk to you later. Bye-bye.